Hello, this is a BTEC Sport and Exercise Science video. We are looking at Unit 2 Functional Anatomy, focusing on the skeleton, but very specifically on D4 ligaments. Now, ligaments are essential in a lot of our joints, and there have been a couple of 4-mark questions on this specific topic. So let's have a look. Now, here's an image of the ankle joint where we see lots of ligaments stabilizing this joint. Now, you may be aware that your ankle is really vulnerable to damage. We go over on our ankle quite easily in a lot of the sports that we play. Just to be clear, this big white structure here is a tendon. That's your Achilles tendon. It's connective tissue. But these white straps here are ligaments. These hold the bones of our lower limb together with the bones of our ankle. You can identify a couple of the tarsal bones, the calcaneus, which is your heel bone. Just buried under there is the talus, which is the main tarsal bone that connects with your tibia and fibula to make your ankle joint. But here are all the other tarsal bones. But the ankle joint is strongly connected or stabilized by ligaments. Over here we've got the hip joint. So this is a ball and socket joint, a condyle and a fossa. You can't particularly see those, of course, because they're buried beneath all of these big, strong, thick ligaments. So our legs are femur, and the head of the femur need to be held tightly into the socket of the ischium, one of our pelvic bones. Remember, we've got the ilium and the ischium are the main pelvic bones that are fused together. The ischium forms the socket, and the femur sits in that. Ligaments are really important for connecting bones and stabilizing joints. Now, there are some very specific facts that you need to learn about these 4 questions, for short answer questions, but also for those big question 11 and 12 questions. First of all, their structure. What are ligaments? What are they made of? They are short, often short, white, fibrous bands of tough but flexible connective tissue. So they've got a little bit of give to them. We don't want them to be so rigid that if we pull them, let's say you went over your ankle, if they were so rigid, they would just snap immediately. We want them to have some give, some flexibility or elasticity. So learn these little phrases. Short, fibrous bands, white fibrous bands of tough but flexible connective tissue. What's the job that they do then? You should know already that they connect bones together at a joint. So here we've got the shoulder joint. These ligaments hold the head of the humerus into the socket of the scapula. They give joint stability. Please associate that word with ligaments, stability. So they connect bones and they provide stability. Now, they're designed to allow certain movements that we want, and they're designed to try and restrict unwanted movements. Because if we have unwanted movements, if our joints move in a way that they weren't designed to move, we're probably going to injure ourselves, we're probably going to damage our ligaments, and they're going to get overstretched, and we'll end up with a sprain. So this is really a summary of the information you must learn. I'm going to go over that in a little bit more detail now. So, key phrases. They allow and permit certain joint movements. So, for example, the ligaments in our knee. So this is the knee. We can tell by this is the patella. This is the tendon from the quadriceps that the patella sits inside, is embedded in, and attaches to our tibial tuberosity down here. And we've got ligaments down the side of our knee, because what we don't want is sideways movements at our knee. We only want flexion and extension in that sagittal plane. So you can just about see behind this front white tendon, we've got cruciate ligaments. You've probably heard of people damaging their ACL ligament. That's the anterior cruciate ligament, this one here. And then you've got your PCL, your posterior cruciate ligament. They crisscross. So they hold the femur and the tibia together, and these collateral ligaments, the side one and the middle one, so the other leg would be this side, so that's the medial ligament and the lateral ligament. Those ligaments try and stop sideways movements, because the hinge joint of your knee wasn't designed to move sideways, it was only designed to do flexion and extension. Okay, so this is just a really nice, easy example of how ligaments allow desired structured movements, but prevent and restrict unwanted movements. Here's an example of where things can go wrong. So if our joint moves beyond its normal range of movement, so your joints are all designed to allow a certain amount of movement, some more than others, but if you go over on your ankle, get your thumb pushed back in a game of football or netball or basketball, apart from the fact it hurts, basically that limb has been pushed beyond its normal range of movement. And that's called hyperextension, depending on which way it moves, of course, hyperextension or hyperflexion. So if your wrist gets pushed back, your finger and your hands get pushed back towards your forearm, that would be hyperextension. If the finger went this way, it'd be hyperextension. If it got pushed that way, it'd be hyperflexion. So going beyond the normal range of movement is called hyper, whichever movement it is, extension or flexion. But these words and phrases are really important to learn. And what you do is you essentially overstretch your ligaments, you damage your ligaments when you do hyperextension or hyperflexion. Here's a very typical example then, ligament injury. If you go over on your ankle, if you roll your ankle, this calcaneofibula, what a name that is, but it actually makes sense. This ligament connects the calcaneus, the heel bone, to the fibula, the bone, the side of your shin. So it's the calcaneofibula ligament. If you roll your ankle, you can damage, either tear, if it's quite extreme, or you can sprain, overstretch this ligament here. So know what a sprain is. A sprain is when you overstretch ligament, when they get, yes, they've got a little bit of flexibility, but it's when they get pulled beyond their normal stretchability. If it's a more extreme overreach, then you would either partially or completely tear that ligament, which would be very unpleasant. And typically we do this by sudden movements where we go beyond our normal range of movement. So you must know what a ligament sprain refers to. We do this a lot too, ankles, wrists, thumb, sometimes knee, if we land funny, or if we kick or throw, kick particularly firmly. Sometimes, you go to kick a ball and let's say you miss the ball, you overextend your knee. That could be a sprain of the knee, the ligaments of the knee. Certainly I've gone over sideways and I've sprained my medial collateral ligament, or doing your ACL. So they're the typical locations of injuries. So there's one last bit of information to appreciate. So if we do loads of training, if we do loads of strength training, our muscles get stronger. But we also want our ligaments to adapt and become stronger. The more we train, the more we exercise, the more we do. So training increases the strength of muscles and tendons, and when your muscles get stronger, they're going to apply more force. They're going to make joint movements happen more rapidly and more powerfully. So in order not to get damaged, our ligaments need to adjust with the training too. It's not just muscles that get stronger and adapt or change. We want our ligaments to as well. And they'll adapt in two ways. They will adapt to, number one, get stronger themselves. They need to be able to withstand these different movements and these different, actions. But also they'll adapt to become a little bit more elastic, so that when for example, this golfer, if they become stronger, they will go through this range of movement much more quickly and rapidly, and we want our ligaments to be able to cope with that rapid stretch without breaking. Unfortunately, a lot of our lifestyle can be seated or static, or if people are sedentary and don't exercise or don't do enough flexibility work, then these connective tissues, like our ligaments and our tendons, can get really stiff, can get tight, can shorten, and that can make us, lose range of movement, but can also make us more vulnerable to injury. So as much as we want to do strength training, speed training, endurance training for our sports, we should also make sure that we incorporate flexibility work for this reason. So let's have a look at a couple of exam questions. There have been 2, as I said, for 4 marks, specifically on this ligament topic. Explain the function of the ligaments in the knee joint during the kick movement. Now, because they've given you the knee and the kicking action as a specific part of the question, ideally you relate your answer to that. So it shouldn't really just be about facts. It should be linked to the action of kicking in your answer. So, as with many of the mark schemes, it gives you options. There isn't necessarily one absolutely correct, perfect answer. There's overlap in these versions. So let's have a look. Ligaments stabilize the joint. That's a functional point because they attach bone to bone. That's a functional point. Therefore, preventing unwanted movement. So this overextension, if she kicked the ball and her lower leg overextended, that would be called hyperextension, and this point is where they're applying it to this particular question. They haven't just said explain the function of ligaments, they've specified linked to the knee in this action. You could also, of course, write about the structure of ligaments. So they are strong fibrous connective tissue. This mark scheme actually said that it was inelastic. I've changed it to being slight. We're having slight elasticity because they do. They attach bone to bone, stabilize the joint. So, okay, can you see the similarity of what you must learn? And prevent unwanted movement or hyperextension. So various things can be acceptable, but you'll see the facts are fairly similar. So again, this question gives you an image, gives you a throwing the ball example, and it wants the function of ligaments during this throwing movement for 4 marks again. So again, it's wanting the same sort of information. Here's the mark scheme: stabilizes the joint, attaches bone to bone, prevents unwanted, reduces the chance of injury, hyperextension, hyperflexion, any similar related appropriate answer. If you gave a little bit of structural information in there about them being tough fibrous bands that are slightly flexible, that would be acceptable too. So that covers the information required on ligaments. What's their function? How are they located at joints so that they stabilize them and restrict joint movements?